right, we're going to do another example. Slope in polar, example 2. Given that r equals 3 minus theta, find the equation of the tangent line at theta equals 0. So as we've discussed in other videos, whenever we hear equation of a line, right, so equation of a line, we need two things. Number one, we need a point, right, x comma y. Number two, we need a slope, which is change in y over change in x, right, so dy dx, right? So we're going to go ahead and find the point, and then we'll find the slope, and then we'll put the two of them together in point slope, and that's pretty much the way this works no matter what kind of math you're doing. So recall that when I go to find that point, right, x equals r, which is 3 minus theta, cosine theta, right? So the x-coordinate of this thing, so x at 0, should be a 3 times a 1, which is a 3, right? And the y-coordinate, so y equals r, which is 3 minus theta sine theta, right? So y of 0 should be a 3 times a 0, which is 0. So what that tells me is that the first piece of information I need is that the point is 3 comma 0, x comma y, right? So that's the first piece of information I need. The second thing I need to do is I need to find my slope. So in order to find my slope, trying to find my red marker, but I seem to have misplaced it, so black marker it is. So the second thing I need to do is find my slope, right? So to find my slope, blue marker it is. So to find my slope is going to be y prime of theta over x prime of theta, right? So to derive y and x, I'm going to use the product rule, right, where my u is the r from the original formula, the 3 minus theta, and my v is cosine. Now you could also do this by distributing the cosine when you derive x, and the same thing with the y. When I derive y, I'm going to make my u the whole 3 minus theta, which was my r originally, and my v sine, and you could again distribute this, but you're stuck with a product rule either way, so I'm just going to do it this way. So when I do this, right, my y prime is going to be u, which is 3 minus theta, right? Sorry, that's a 3, right? U dv, which is going to be cosine theta, plus v, which is sine of theta, du, which will be a negative 1, right? So that's my y prime of theta. When I do my x prime of theta, it's going to be u, which is 3 minus theta, dv, which will be a negative sine, plus v, which is the cosine of theta, du, which is again that negative 1 that's in front of the theta. So when I go to find my tangent slope, which I'm going to dub m sub t, I want y prime of 0 over x prime of 0. So when I plug in my zeros, I'm going to get a 3 minus 0, which is just a 3, times cosine of 0, which is a 1, plus a bunch of 0, because sine of 0 times the negative 1 is going to be a 0 times the negative 1. On the bottom, I'm going to get a 3 minus 0, which is a 3, times a big old 0, so that's going to be a wash, plus a 1 times that negative 1. So I'm pretty sure I get a 3 on top of a negative 1. So my tangent slope, which I'm going to call m sub t, is a negative 3. I then take my point and my slope, and I put the answer in the laziest possible way, which is point slope. Y minus the y value equals my m, quantity, x minus the x value. And that is the best possible version of the answer. Sure, you can totally distribute that negative 3. You can ignore that 0, and you could make this a y equals negative 3x plus 9. But if you accidentally add wrong, or multiply wrong, or do something else wrong, you're going to be really surly that you took a yes and made it a no. So just be careful if you choose to clean up an answer.